solving some problems related to digital health. So mostly I will be discussing about two approaches. One is the development of some virtual doctor or the conversational agents. So basically how we can develop some conversational agents with the help of deep learning, machine learning techniques. And also I will discuss about the development of some motivational chatbot. So what is the artificial intelligence? So basically artificial intelligence is a very popular branch of computer science. So that concerns with the building of intelligent smart machines capable of performing intelligent tasks. So basically by using the artificial intelligence tools and techniques, we can make a machine intelligent enough. So a machine can behave like a human being with the use of AI. So with rapid advancements in deep learning and machine learning, the tech industry is transforming radically. So basically, that by the use of the AI technique, we are transforming the nature of work, learning and learning to work. So AI is having many different paradigms, and machine learning and deep learning are two important paradigms under AI or the artificial intelligence. So AI can be used in different sectors. So you can select any particular sector of society and you can see an application of AI there. So like you suppose in the human resource management, in fraud detection, so whether a particular transaction is fraudulent or a particular customer is fraudulent or not, that can be easily decided by the AI-based technique. Or the knowledge creation or the research and development, then pricing and promotion, customer insight, risk management and analytics, customer services, real-time operation management. So in every sector, you can see an application of AI. So like in predictive analysis, AI is having an application. Then the customer experience. So if you want to improve the customer experience, we need to utilize the AI. So that predicting some cost or predicting the market value of a particular product, we can utilize the AI-based technique. So AI has applications in almost all the sectors of the society. So now let me discuss about the what do we mean by the virtual assistants. So basically, the virtual assistants are called the chatbots. So these chatbots are very popular nowadays because in our day-to-day life, we are using the Alexa or the Siri. So this Alexa or Siri are examples of the chatbots. And this Alexa and Siri are basically some kind of personal assistants. So we can ask for any kind of service from the Alexa. We can give some instructions to Alexa and Alexa can execute it. So we can ask for the weather update from the Alexa, or we can ask for the play music in Alexa. And Alexa is always a personal assistant. So Alexa is following the instructions given to it. So, there are different types of virtual assistants. There are some virtual agents. There is a personal assistant. There is a virtual counselor. There is a diagnosis agent. Like the virtual assistant can also be used in the medical domain. And that is basically the diagnosis assistant. Then, the virtual agent can also be used in the customer care as a customer care representative. Like we know that in many banking sectors or any customer care representatives are basically replaced by the chatbots. So in customer service center, chatbots are heavily used. Then nowadays, chatbots are also used as a sales agent. So basically, that in order to sell a particular product, and the sales agent are very intelligent enough, because selling a product is very, there are much intelligence is needed. Like you need to have the persuasion and the persuasion and also the negotiation capabilities. Like suppose the user wants to purchase a product, so the user first gives the requirement basically gives the requirements or the specifications, and then the sales agent used to see the requirements and the specifications, and they used to search in the database. Now in the database, maybe some products are matching, some are not matching. So maybe in order to sell a particular product, the sales agent used to pursue the user. So this persuasion is having several strategies. So like we can have the persona based persuasion. So if we know that the person is a good photographer, then the persuasion can be done based on the camera quality. If the sales agent knows that the person is very emotional, then maybe it can utilize some emotional appeal. Or if already the sales agent knows that the customer is very logical, then some logical reasoning can be used for the persuasion. So the persuasion can be of different types. So there are different types of persuasion strategies, and any of these strategies can be utilized for the persuasion purpose. And once the product is fixed, the next is the negotiation. So negotiation can be done on the cost. So basically, the sales agent and the customer can negotiate on the price. So this way, the virtual agent is having many applications in almost every sector of the society. So virtual assistants, so basically humans are interacting with the computers, and they are trying to solve some particular task. So these virtual assistants are also called the task-oriented virtual assistant. So there are several chatbots or the virtual assistants, and they used to interact with the humans, and that way they are called the task-oriented virtual assistant. So there is a concept called the human-inspired learning. So learn a task more effectively and quickly if guided by an experienced individual or the learning guidelines. So basically, that there is a human behavior or the experience. So data, the data is basically carrying this experience, and then with the help of the data, we are learning, we are teaching the machine learning, deep learning models, and as a result, the virtual assistant is basically built. So basically, data is the knowledge here, or data is the experience here. So data is the teacher, and basically data teaches the machine learning, deep learning model, and that way the virtual assistant is basically developed. So that this virtual assistant is intelligent enough. It can successfully to solve a particular task, and also it can accomplish the task in less time, and also it can learn from the failed attempts. So basically, the virtual assistant is very intelligent enough, so it can successfully accomplish a particular task, or it can accomplish the task in less time, or it can also learn from the failed attempts. So this way, virtual assistants are very intelligent. So this is the overall diagram of the virtual assistants or the dialogue systems. So you can see like suppose the user is uttering a utterance, user is saying something. Now there is an automatic speech recognition module. So this automatic speech recognition module is basically translating the speech signal into a text signal. So basically it is translating the speech into text, and then this text is basically analyzed further. So there are two modules, spoken language understanding module and the dialogue state tracking module. So spoken language understanding module's task is to understand the user's intention or to extract the important information from the user's utterance. So here the input is a text, or the after the speech to text, we are getting the speech version of the text, and that is given as an input to the spoken language understanding module. And the spoken language understanding module is having three sub-modules: dialogue act classification, intent detection, and the slot filling. So dialogue act classification means to identify the communicative intention of the speaker, like whether the speaker is asking a question, or it is an open statement, or it is a command, or it is a greeting. So the category of the utterance is called the dialogue act classification. Then comes the intent. So intent means to identify the user's intention. So what the user is trying to say, what is the intention behind the utterance. And the slots are the important information which are present in the user's utterance. So all these, all these things are identified from the, from the textual utterance, and that gives us a state information, and that is called the dialogue state tracking. So all this information, the dialogue act classification, the intents, and the slot values are given as a state to the dialogue state tracking. And now it is given as a information of the dialogue policy. So dialogue policy is a reinforcement learning based agent. So it basically maps the state into action. So basically, in reinforcement learning, it is a Markov decision process where there is a set of states, there is a set of actions, and a policy basically maps the states into action. So this mapping is done by the dialogue policy or the dialogue management. So it is a reinforcement learning based agent, and it basically maximizes the rewards. So for each action, for each state, when an action is taken, there is a reward or there is a penalty. So accordingly, basically, so basically, according to the dialogue policy is basically optimized. And finally, there is a natural language generation module. So this natural language generation module basically, translates the, like this dialogue policy is taking an action, and this action is translated into system response by the natural language generation module. So basically, dialogue policy is taking and mapping a state into an action, and this action is translated into system response by the natural language generation module. And finally, there is a text to speech module, which is translating the system response into the speech signal. So this is the overall diagram of the end-to-end dialogue system. So user is, saying something, and then it is translated into text. Then all the processing are done on text. And finally, again, text is translated into speech to give the response to the user. So this is the overall framework of end-to-end dialogue system. So now, what is the need of what is the automatic disease diagnosis? So the disease diagnosis is the primary and the crucial stage of any medical treatment process. And if you know that nowadays telemedicine facilities are becoming very popular, and especially in the rural India, where the number of ratio between the doctors and the patients is very alarming. So there are very less number of doctors compared to the patients. So the world falls short of 7.2 million medical workers, 30 millions by 2030. So most of the countries across the globe have only 0.01% to 0.1% doctors. A survey done by WHO shows 35% US adults had utilized self-diagnosis tools before consulting with the doctors. So basically, the US adults are mostly mostly using the, that this the internet for diagnosing some diseases. They are searching their symptoms in the internet, and accordingly they are taking some decisions. So basically, the telemedicine or the internet, the online medicine are becoming very popular. So the idea is that can we develop a virtual assistant which can perform the symptom investigation? So thus efficient time utilization of doctors and early diagnosis are two key motivations for disease diagnosis assistant. So here you can see, like, suppose the patient is visiting a hospital and the patient is initially having a self-report. So in the self-report, patient has mentioned about his or her own set of symptoms that he or she is suffering from. Now, based on this self-report, the receptionist can guide the patient to a particular department. So in big hospitals, there are several departments like eye or the gynecologist or the ENT. There are several departments in a particular hospital, and based on the self-report, the receptionist used to guide the patient to a particular department. And now, in the department, there are many senior doctors and there are some junior doctors. So these junior doctors are responsible for the symptom investigation. So they used to ask about some further symptoms, and then they used to generate a report. And this report is basically is given to the senior doctor, and the senior doctor basically prescribed a medicine, basically diagnose a disease, and then prescribed a medicine. So basically, you can see, like, this is basically virtual doctor. So like it is doing the symptom investigation. So depending on the self-report, it is asking some additional symptoms from the patient, and then the report is generated, and this report is given to the senior doctor. And based on this report, the senior doctor is prescribing the medicine, and also diagnose the diseases. So basically, our task is not to replace the doctors, but to develop a AI-based assistant which can help the doctors. Like we can basically save some time of the doctor, and which can help in symptom investigation. So that this is the idea. Like the patient is, hi, I have been suffering from fever for a few days. Also, something happened in my mouth. Please see this. So now the diagnosis assistant is asking, did you recently vomit? Yes, I vomited this yesterday. So do you have eye pain? The patient is saying, yes, I am feeling so. Now, have you observed any skin rash in your body? So now here you can see the patient is not able to express. Patient is not having the information about some symptoms like skin rash. Maybe the patient is not aware of the name. So patient can simply show some images. Like patient is showing some image of, of his hand. And now from the image, maybe the agent can easily extract the information that this is the information about the skin rash. So I am not sure, but please see this. So basically, you know that from the image, the patient will understand that yes, basically this is the image of a skin rash. So finally, report is generated. The patient suffers from the following symptoms: fever, mouth ulcer, vomiting, eye pain, and skin rash. The most likely disease is erythema multiforme. The images are shown below. This way, a report is being generated. So this, that report is basically being generated, and then this report is, yeah, and this report. Hello. Yeah, and then yes. Any question, Satyajit Azhar?
Yes, ma'am. I have one question. So, how much we can trust, ma'am, this virtual assistant in diagnosing and all in healthcare? Because the
Yeah.
data
So
we don't know how they are trained enough. The training data set.
yeah, correct. So I will show you. I will show you the accuracy or the the prediction accuracy of this. So you can see these are not very accurate, but as I told you that as the final decision is taken by the doctors only, so it's a simply aid or a help to the doctor. It is simply saving some time of the doctors. So that's why we can rely on this. And if there is any error, because we are still we build a preliminary model, and we are now working on how to improve this further. So basically data set is a big challenge because getting a medical data set of this kind is very difficult. So basically we are how we are developing the data set, I will tell you. So we in our lab only we are preparing this data set with the help of a doctor. So we have a collaboration with AIMS Rishikesh. So in AIMS Rishikesh there is a doctor, Dr. Meenakshi. So she is helping us in developing the doctor. She is only validating the outputs of this virtual doctor. So yes, so I will mention this in my slides. Okay. So but yes, we are still working on this. So some preliminary prototypes are already built, and now we are working on this to improve this further.
Okay, ma'am. Ma'am, if doctors are biased, then how they are going to label the data set? I mean.
Yeah, so biasness, so we assume the doctors are not biased because here
I mean,
it
if
is
their
only.
knowledge is somehow biased, then.
Oh, acha, then there is a problem. Yes, that is an issue. But that's why we are annotating using three doctors. Okay, not only a single doctor, but there are three doctors. So three doctors are in parallel. They are basically annotating the data, and then we are taking the majority voting. Okay, so this annotation is done based on three doctors.
Yeah.
So
Okay,
that
ma'am.
way, if there will be a biasness by a single doctor, maybe as we are considering three doctors, it will be overcome.
Okay. Thank you, ma'am.
Yeah. So basically, this is the kind of prototype that we have developed. So we developed this kind of diagnosis assistant. So it's simply a kind of a helper to the doctor. So it is helping the doctor in the symptom investigation. And as you see, this is called the multimodal information processing, because now the patients can express their symptoms not through text but also through the images. Like in some cases, the patient is expressing the symptom through text, like I vomited yesterday. This is a textual representation of the symptom. But in some cases, it is also he or she is also showing some images. And from the images also, now the agent can easily understand, the assistant can easily extract the symptom information from the images. So this way, this is a, that this way, this is a kind of a multimodal information processing. So one of my Abhishek Tiwari is my PhD student. So basically, he got the PMRF, the Prime Minister Research Fellowship. Fellowship. This is a very prestigious fellowship. So a student can avail this fellowship, and then he can get a stipend of 75,000 rupees per month. And he got selected for this fellowship for this particular project, the virtual doctor development of some virtual doctor, and he is basically working on this problem statement. And as you know, that developing a virtual doctor is not so easy. As I mentioned, that data set creation is a major part, because there was not any multimodal data set existing for this particular domain. So we created our own multimodal data set. And then there are many problem statements related to this. One is that how can we basically, this virtual doctor is not having any medical knowledge. So how can we infuse some medical knowledge into this? So for that, we have utilized a knowledge graph. So this knowledge graph is having all information about the symptoms and the diseases. So a disease is having multiple symptoms, and then symptoms are also connected with the diseases. So all this information are basically done with the help of the, with the help of this knowledge graph. So by using the knowledge graph, we are trying to infuse the medical knowledge into the virtual assistant. And also, when you are interpreting a particular symptom, like when suppose user is showing an image and you need to understand the symptom information present in the image, that time context plays a very major role. So in which context the patient is showing the image, that is very important. And we are basically trying to develop some context aware, the disease diagnosis assistant. So this disease diagnosis assistant is trying to understand the symptom information based on the context. So then there is another task, symptoms are known by their companies. So basically what happens is that men are known by their company if it keeps. So basically, that when we are, some symptoms are very common, like cold, cough, fever, these are very common symptoms. But when they are associated with some other symptoms, then we can easily understand the disease. Because cold, cough, fever, these are very common symptoms. But when they are associated with some other symptoms, then we can easily understand the disease name. Then this multimodal automatic disease diagnosis, because in some cases, as we are dealing with the patients from the rural India, and there are many uneducated patients, maybe they are not aware of the many of the symptom names, maybe they are not aware of the medical terms of the symptoms, but they can simply show the image signs of the symptoms, like the mouth ulcer, skin rash, or red eye. So the names of the symptoms may not be known to the common people of the society. So maybe they can simply show some images, and if the virtual assistant can extract the symptom name from the images, then that will be of very much use. So basically we are developing some multimodal automatic disease diagnosis system. And the fourth is basically learning from failures. So that the doctors, the real life doctors, always learn from the failures. So you have to develop some diagnosis assistant that also learns from the unsuccessful diagnosis. So like if there is an unsuccessful diagnosis, then the doctors used to learn from the failures. Similarly, humans learn a task through both successful and unsuccessful attempts in real life. So basically, can we somehow develop a virtual assistant which can also learn from the failures? So basically, so that it can keep on learning the new things. So these are some four problem statements that we worked on. So let me now discuss about the first problem statement, a knowledge-infused, context-driven dialogue agent for disease diagnosis using hierarchical reinforcement learning. So basically, you can understand that the task is you have a set of symptoms. Maybe you have already asked about few symptoms from the patients. And now based on these symptoms, you have to understand the disease. So, it's a very exponential problem statement, because if you have n number of symptoms, then the possible number of cases will be to the power n minus 1. Either a symptom can be absent or symptom can be present. So now we have to, map this information to a particular disease. So we have to emphasize the need of knowledge-aware, experience-guided symptom investigation. So in real life, doctors usually do the opposite. So when a patient visits the doctor, based on the self-reported symptoms, doctors assume some disease, and then the doctor does some symptom investigation just to basically make sure that yes, that particular disease is correct. So basically, it follows a backtrack path. So based on the self-report, it assumes some disease, and then it follows the follows the backtracking, like it in order to confirm this particular disease, it asks for some additional symptom information from the patient. And if the patient basically confirms those symptoms, then that particular disease is that it says that the patient is suffering from the particular disease. So that these hypothesize a set of candidate diseases depending on informed symptoms, current context, and first inspect symptoms of candidate diseases. So this is also called the symptom exploration and exploitation problem. So basically, we developed a knowledge infused. So as I mentioned, this virtual assistant is not having any medical knowledge. So we have to somehow infuse the medical knowledge into a virtual assistant, and then that can only be done with the help of the some knowledge graph. So there is a medical knowledge graph is existing. So this medical knowledge graph is having information about all symptoms and all the diseases. So a disease can have multiple symptoms, and this knowledge graph is having information about all the diseases and all the symptoms. So a novel knowledge infused context driven task oriented virtual agent we are developing for automatic disease diagnosis using hierarchical reinforcement learning. So we also developed a hierarchical disease classifier. So this disease classifier first identifies the department name, because that as I mentioned, some for a particular department there are several diseases. Like for the eye department there are some diseases. For the gynecologist there are some diseases. For the heart there are some diseases. So we need to first identify the department name, and then for a particular department we can go for the fine grained analysis, and we can somehow predict the disease name. So basically we developed this hierarchical disease classifier, and we have shown a huge improvement over the current state of the art model. So diagnosis success rate is improved by 7%. So this is our overall architecture. So this master is nothing but a department basically our department classifier. So basically first, this is a receptionist. It behaves like a receptionist. So first, the receptionist used to decide about the departments, and then each department is following its own policy. So there are some higher level policy and there are some lower level policies. So now there is a hierarchical disease classifier. So the hierarchical disease classifier is first identifying the department name, and then for each department there are some specific diseases. So then there is a potential candidate module. So this potential candidate module is basically working as a knowledge graph. So this pathogen is nothing but a knowledge graph. So it is giving the enough context, and accordingly the disease is basically it is giving some clues to the dialogue manager that these are the potential symptoms, and accordingly some symptom information can be asked from the user. So this is the overall diagram. So basically it utilizes the deep learning and also the reinforcement learning. So by using the reinforcement learning, we are basically you identifying the correct action, and that action is translated into system response. So so basically we have utilized these 4 data sets. So basically we have not worked with the Chinese version. So there are 4 data sets in this automatic diagnosis system, RD, DX, which are in Chinese languages. And there are 2 English data sets, SD and the synthetic data set and the MDD. So these 2 data sets are written in English. So in SD data set, there are 30,000 users and 90 diseases and 266 symptoms. And the diseases are dengue, fever, diabetic, etc. And symptoms are sore throat, fever, ankle pain, shoulder cramps, etc. And the MTD is the medical data set. Here there are 1912 number of user goals, and number of diseases are 12. And then the number of symptoms of 118. So that and here the diseases are basically this esophagitis, enteritis, asthma, etc. And the symptoms are dizziness, chest lightness, burning sensation behind the chest, breastbone, etc. So each sample in the data set is having this kind of loop. There is a consult ID, there is a disease tag, there is a group ID, and then there is a goal, disease, and then there is a explicit informed slots. there is a implicit informed slots. So this is the each sample of the data set looks like this. So you can see these are the learning curves. So we develop different versions of the proposed approach. So knowledge infused, the system is knowledge infused our investigation. The knowledge infused context driven hierarchical disease classifier, and also we have shown that we have done an ablation study, like what will happen if we remove the knowledge part there, what will happen if we remove the hierarchical disease classification from there. So these are the plots of the success rate. So you can see, like, that knowledge infused hierarchical disease classifier is achieving the the highest success rate, and also the dialogue length is also limited, and it is also having the highest average match rate and the highest symptom rate, basically success rate. So basically, that this way we can show that these curves demonstrate the utility of the knowledge graph and also the utility of the hierarchical disease classifier. So you can see these are some results we have done. We have done comparative study with the existing techniques. So we have compared our approach with the several existing approaches with respect to the success rate, dialogue length, average matching rate, SIR, and the disease classification accuracy. So currently we are getting the accuracy of basically that 59.75%, which is not very high. This is on the SD data set, and for the data set, we are getting the accuracy of 81.79%. So this way we are getting around 80% accuracy. So MD data set is having less number of diseases, and SD data set is having more number of diseases. So that we also did an ablation study, and we have shown that our proposed approach achieves the highest disease classification accuracy and also the other highest scores in the other metrics. So these are some results. That these are the disease, endometrial hyperplastia. So now there is a self-report, vaginal bleeding after menopause. Now there are some implicit symptoms. So you can see this is a conversation. So the proposed model accomplishes significant improvement over the current state-of-the-art method, which firmly establishes the efficacy of doctor's diagnosis method inspired KICD diagnosis approach. So we also developed a hierarchical disease classifier, which is giving us the accuracy of around 49.74%. And this hierarchical disease classifier lacks negative symptom information. So next, we have also worked on the other problem statements, like, symptoms are known by their companies, towards developing a virtual diagnosis assistant with association guided symptom investigation. So basically, that we are developing some association guided symptom investigation where symptoms are known by their companies. So condition induces various effects, and these effects collectively represent the cause. So a word is known by the company it keeps. Similarly, symptoms also exhibit the association property. One symptom may strongly suggest another symptom's existence or the non-existence. So we have investigated the role of symptom association in diagnosis process and proposes a novel association guided symptom investigation incorporated diagnosis assistant. So this is our proposal. So basically, there is a module that we are developing a graph. So this graph is developed based where each node is a symptom, and we are trying to measure the association between two symptoms. So in how many cases two symptoms are co-occurring? For how many diseases these two symptoms are co-occurring? And from this association, from this graph, there is an association module which is giving us some association score. So basically, if suppose already user has asked for what there is a current requested symptom, now based on this current requested symptom, we are identifying the K other symptoms which are highly associated with the current symptom. And then there is a recommendation module. So this recommendation module will give this K number of relevant symptoms to the lower level policy. And the lower level policy can basically select one of the symptoms from this K number of symptoms. And then there is an association module, so which will give us a reward. So if suppose if the reward basically depends on the association score. So if suppose the lower level policy has asked for a basically lower level policy has asked for a particular symptom, and that symptom is very much related to the current requested symptom, then there is a reward based on the association score. So basically, you know that this is the architecture of the association guided symptom investigation and diagnosis dialogue system. So you know here also we are following a hierarchical policy. The controller is a higher level policy, which is the the kind of receptionist, and then the receptionist is invoking any of the departments, and these departments are basically that there is a diagnosis state tracker which is tracking the diagnosis state, and then there is a patient, and there is a disease classifier which is doing the hierarchical disease classification. So now the novelty is this graph. So this graph is drawn based on the data set. From the data set, we collected the frequency of occurrence, co-occurrence between two symptoms, and according to the age weight is calculated. And based on the age weight, the recommendation module is giving the K recommendations of the next set of symptoms, and also the reward is calculated. So if a particular symptom is asked, which is very much correlated with the current symptom, then there will be more reward. Otherwise, there will be a penalty. So we we have shown the results on the two data sets, English data sets, and you can see that our proposed approach is having the diagnosis success rate of 55.76%. And in another major objective is that we cannot keep on asking irrelevant symptom information to the patients. Then the patients will get irritated. So basically, one objective is to minimize the dialogue length also. So basically, minimal number of dialogues, we have to do the appropriate symptom investigation. Then there is an average matching rate, then also the disease classification accuracy. So we are getting the disease classification accuracy of 56.16%. So here you can see the results that the proposed association guided symptom investigation and disease diagnosis outperforms all non-association guided baselines in the state-of-the-art model. So indeed, symptoms are highly, like this association information is helpful. Like when we are considering the association information between symptoms, then that is helping us in predicting the correct disease. So now you know that the next work emphasizes that all symptoms of a disease are not equally important. So basically, we have to do some selection of the important symptoms. Like in the machine learning algorithms, feature selection plays a very important role. So all the features are not important for developing a machine learning classifier. So we have to carefully do a symptom, feature selection. So similarly, a disease may have many symptoms, but they are not all equally essential or distinctive to the disease. So doctors usually diagnose patients by inspecting only a few symptoms, despite the fact that the diagnosed disease has several symptoms. So basically, a disease may have many symptoms, but we have to carefully select a subset of symptoms based on which the prediction or the diagnosis can be done. So we have to investigate the role of symptom importance in the disease diagnosis process, and we propose and build a novel symptom importance aware diagnosis framework using feature selection and the hierarchical reinforcement learning. So here, this is our novelty. So other parts remain very similar. Like there is a master, which is the higher level policy, because we are developing a hierarchical reinforcement learning based policy. So master will behave like a department, like the receptionist, which will guide the patient to a particular department. And each department is having its own lower level policies. And the departments will basically ask for the symptoms, for the symptoms. So now, but basically there is a feature assessment procedure. So this feature assessment module will basically assess the importance of individual features or the individual symptoms, and then a set of symptoms will be selected, and these symptoms will only participate in disease classification. So basically, there are some common symptoms like the fever, cough, cold, which are very common across all the diseases. And maybe these symptoms are not important for predicting the diseases of all types of diseases. So we need to select a subset of the symptoms and then based on the symptoms only we have to predict the disease. So basically this is the this is the task here. So we are doing a symptom assessment module, and by using the symptom assessment module we are selecting a subset of symptoms, and based on the symptoms only the disease classification is done. So here also you can see that this is the result of our approach. So we have done different types of feature selections, and our feature selection finally we are getting 240 number of symptoms and the highest accuracy of 80.6%. And with this, when we are developing the model, our success rate is 52.50%, and we are taking 10 point minimum in an average 10.30 number of dialogues, average matching rate of 11.24, and also disease classification accuracy of 51.78%. So here you can see like one example, like hi, I am feeling headache since few days. Can you please tell what might be the problem? So then the dialogue agent is saying, hi, I am here to help you. Are you also feeling anxiety and nervousness? So the patient is saying, no, I don't think so. Agent is saying, great. Are you feeling dizziness? The patient is saying, no, I don't have dizziness issue. The agent is saying, do you feel nausea? The patient is saying, yes, I am feeling nausea. Agent is saying, yeah. Do you have also neck pain? Patient is saying, yes, I am feeling some neck pain since some days. Dialogue agent is saying, okay, you are most likely to have cerebral edema disease as per the symptoms. Patient is saying, okay, thanks for the assistance. Dialogue agent is saying, thank you. So this way the conversation ends. So basically you can see that symptom importance our diagnosis model performance basically improves. So basically we need to select some important symptoms, and based on those important symptoms only we have to predict the disease. We should not consider all the diseases, all the symptoms, because some of the symptoms are very common across all the diseases. So before predicting the correct disease, we need to carefully select a subset of symptoms, and based on the symptoms only we have to predict the disease. So we observe that the agent informs the right disease with only patient's self-reported symptoms, where patient's self-reported symptom is quite unique for its corresponding disease. So incorrect disease prediction, but the predicted disease belongs to the same group of actual disease. So in the next work, we have done multimodal automatic disease diagnosis assistance. So conversations may also contain some images. Like if suppose the agent, the patients are not aware of some symptom names, then patients can also show some images, and from the images also the agent can easily extract the symptom information. So in real world, when we consult with doctors, we often report and describe our difficulties or symptoms with the visual aids. So basically, sometimes the patients have to report the symptoms using the images. And from the images only, we have to extract the symptom name. In fact, many people are unacquainted with several symptoms such as mouth ulcers, skin growth, etc. And they are not aware of the medical terms of these symptoms. So in those cases, they can simply show the symptoms to the signs. And from the sign information, the symptom name can be extracted. So we basically developed two modules: symptom image aided symptom investigation and diagnosis, and dialogue context aware symptom image identification. So we developed basically these two modules. So we developed a multimodal disease diagnosis virtual assistant using hierarchical reinforcement learning. And this multimodal diagnosis assistant can extract the is able to understand is able to extract the symptom information from not only the textual utterances but also from the images or the signs of the symptoms expressed by the patients. And also this basically we are given an image, we have to identify the symptom information. So this is basically context based, in which context the patient has shown the image, that is very important for proper symptom identification. So we are developing a context aware symptom image identification. So basically here the context is given as an input, and also the image is given as an input, and then the agent basically this module is extracting the symptom name from this image. So we are developing as and when we started research in this particular area, we identified that there is no multimodal diagnosis dialogue data. So basically, we also developed a multimodal diagnosis dialogue data for this very purpose. So this is the overall architecture. So many things are very common like the previous one. So there is a controller which is the receptionist, where there is a higher level policy. Now this the task of the high level policy is to appropriately decide the departments. Now each department is having a lower level policy. And now basically there is a multimodal disease diagnosis state tracker. So this basically user is saying something. So user can either show in text or can either show in image. So that from the text also we are extracting the information, symptom information, like the symptom information like fever, etc., can be extracted from the text. And then the user can also show some images, and from the images also we can extract the symptom information. And then together we can provide this as a dialogue state tracking. And then this dialogue state tracker can be given to a disease classifier, and the disease classifier can predict the disease. And now that this diagnosis assistant, this virtual doctor is used for the symptom, basically the symptom investigation. So depending on the current set of symptoms, the agent is asking for the next symptom. So that and then that and basically it is by the use of the natural language generation module, the appropriate the action is translated into the response. So that this is the input that hi, I have been suffering from fever for a few days. Also something happened in my mouth. Please see this. So here there is an image also. So from the image, from the we have to extract that this is the information about the mouth ulcer. And now there is a state tracking. So one fever is extracted from the text portion, and from the image we are extracting the symptom information, mouth ulcer, and these two are given as a state information. And now based on this state information, this controller policy will be invoked. Accordingly, the departments will also be in lower level policy will be invoked, and the lower level policy will be responsible for doing the symptom investigation. And finally, the report will be generated, and the report is that the patient is suffering from fever, mouth ulcer, vomiting, skin rash, and chorea. The most probable disease is erythema multiforme. Also, the patient's mouth image is shown below. And now this report can be given to the basically senior doctors, and the senior doctors can basically prescribe the medicine and also can diagnose the disease and verify the disease basically. So that this is our context aware image identification module. So like we are not only inputting the image but also the context. So in which context the user has shown the image information. So these two are given to this particular module. And here for the text portion, we are using the bar, and for the image, we are using the dense net. So features are extracted from the dense net, and from the from the context, we are passing through the clinical bio bar, and then we are concatenating the feature vectors, and then we are passing through the softmax, and accordingly the basically the classification of the symptom is basically done. So the symptom information is basically extracted. So here but there are two modalities. One is the text modality, and another is the image modality. So from the text modality, fever information is extracted, and from the image modality, this key and this basically cloudy vision is basically extracted. And then together we are trying to identify the symptom. So as I mentioned that when we started doing research in this. So, that when we started doing research in this particular domain, there was no dataset existing. So, the number of dialogues is 1500, and number of utterances is 6936. So, so basically these are the things that number of dialogues is 1500, and the number of utterances are 6936. And the utterance tags are intent, symptom, and the image information. And average dialogue length is 4.62, and there are only two. So basically, that the number of the average dialogue length is 4.62, and the number of intents are basically 2, and the number of diseases are 90, and the number of symptoms are 266, and the number of visual symptoms are 17 plus 3. So 17 are basically, the textual symptoms, and 3 are basically visual symptoms. So basically, this is we identified three visual symptoms, and total number of symptom images is 1805, and number of multimodal utterances is 725. So this is our data set statistics, and these are some new few multimodal symptoms. So skin irritation, mouth ulcer, skin growth, eye redness. These are some examples of the multimodal symptoms. So like this is an observed conversation for the our data set. Like, hi, I have been suffering from fever for a few days. Also something happened in my mouth. Please see this. So now the age diagnosis assistant is asking, did you recently vomit? Yes, I vomited yesterday. Do you have eye pain? Yes, I am feeling so. Have you observed any skin rash in your body? I am not sure, but please see this. So basically, he or she is showing some skin rash. So the patient suffers from the following symptoms: fever, mouth ulcer, vomiting, eye pain, skin rash. The most likely disease is erythema multiforme. The images are shown below. So this is an example of our data set. And in our data set, there are some multimodal symptoms, and also there are some textual symptoms. So basically, we talked with the AIMS Rishikesh Dr. Meenakshi, and with her help, we identified these four symptoms which can be expressed using images also: skin irritation, mouth ulcer, skin growth, and the eye redness. So these are the results. So basically, these are the results of our, the symptom image classifier. So with the context window of 3, as I mentioned, that we have developed some context-aware image identification module. So context plays a very major role, and with the help of the context window of 3, we are getting an accuracy of 88.34% and a font score of 88.24%. And also you can see that the results. So basically, this is diagnosis rate, success rate, dialogue length, average matching rate 2, and the dialogue and disease classification accuracy. So we are getting around 48.90 accuracy, and also average matching rate of 10.12, average matching rate 2 of 31.54. So there is an improvement over the unimodal baselines and of the state-of-the-art model. So the multimodality not only helps in improving the accuracy, but also helps in satisfaction. Hello, any question? So humans, we have also done a manual evaluation, and it has been shown that if suppose when that users, when the human can express the when the human is can express the symptoms through images, sometimes they are more satisfied. So there is a positive correlation between the diagnosis success rate and the dialogue length. And yes, dialogue context basically helps in proper identification of the symptom names from the images. So indeed, context helps in identification of symptoms from the images. And this multimodality basically helps, gives users more choices, because now the users can express themselves not only through text but also through the images. So now let me quickly discuss about our next work. So basically, basically here we have developed a motivational chatbot. So we developed a data set for the motivational dialogue systems, a large scale data set for the motivational dialogue system, and application of natural language generation to the mental health. So basically, we developed a data set for the motivational dialogue system, and then we also developed the chatbot for the mental health. So that the motivation is very clear, that that many people are suffering from many mental disorders, especially during the COVID-19 timing, when there was a complete lockdown. Because of the no physical activity, or because of no interactions, many people were suffering from the some mental disorders, and the depression is one of them. So depression disorder is a widespread and serious medical illness causing humans worldwide. So if there is a survey by the WHO, World Health Organization, which estimates more than 300 million people worldwide are affected by the depression, and it will keep on increasing. And there are many students who are also suffering from depression. So when someone, and there is a stigma It is a social stigma that even though we are suffering from some depression or some mental illness, we do not want to visit a doctor because there is a stigma in the society that if you are visiting a psychiatrist, then people will tell you that you are a mad person. So basically, the poor access and the stigma and the discrimination likely limit the clinical care to only 14% of those affected. So 45% of the world's population lives in a country with less than one clinical psychiatrist per 1 lakh mentally ill patients. So basically, that the motivation is very clear that the global initiatives to reduce clinical depression are survey-based methods using phone or online questionnaires to identify depression. So, there are some online questionnaires, and by answering those questionnaires, the psychiatrist can easily identify the basically the mental illness, like the severity of the mental illness. So mental health professionals are very much limited, and that this is also the issue is very alarming. The number of mental patients and the mental health professionals is very alarming, and lack of early informedness for the MHPs leads to poor decision making, resulting in late intervention, causing deterioration in the quality of life. So, can we develop a AI-based assistant which can help, which can act as a fast point of contact? So, if suppose some person is suffering from some mental illness, then this this chatbot or the virtual assistant can act as the first point of contact, and then it can basically simply try to motivate the user. So its task basically it will be a shoulder to cry on. It will work as a friend, because whenever we are suffering from some depression, we need a friend who can simply listen to our problem and only a shoulder to cry on. So basically, this AI, this assistant will work as a as a basically this kind of motivational chatbot, which will try to simply motivate the user. So when we started working in this particular domain, we identified that there is no such data set existing. So we created a large scale data set called the Motive, consisting of dyadic conversations between depressed and the despondent users and the virtual assistant. So the VA's effort is directed towards comforting and allowing the users to share and express their thoughts, moods, feelings, emotions, struggles, and the worries. So the virtual assistant should impart optimism, hope, motivation, which are identified as crucial affective factors to uplift the spirit of the users in distress. The virtual assistant should be competent and proficient enough to give user a natural human-like experience by responding empathically and affirmatively. So basically, we have this agent we have developed. First, we developed a data set. So basically, when we started working in this particular area, we identified that there is no such data set existing. So my PhD student Tulika Shaha, who is now a faculty in the University of Liverpool, UK. So she basically started this particular research. She was very much motivated to do something in the field of mental health. So that we crawled data many websites like some SAM, BHA, Ask a Patient, Daily Strength, WBMD, Ginger, Psychocentral, Health Rhythm. So there are many such websites. So we basically, somehow identify these websites, and then we crawl some data. And these are the websites where, a patient can anonymously register in these websites, and there are many such users who are suffering from some mental disorders, and then they can simply discuss amongst themselves. Like simply, if I am a mental patient, then maybe I can register anonymously without revealing my name or the gender or the age in this particular website, and then I can ask any question, and there are many other support seekers, and they can basically provide some answers. So we took permission from one of these websites, Psychocentral, and then we crawl some data from the Psychocentral. But the Psychocentral, basically, the Psychocentral is an online web-based platform for anonymous users to share their state of mind, feeling, and worries, and seek help and advice from other users having similar experience in terms of mood, difficulties, and the grievances. So we crawl some data from the Psychocentrals, around 5.5k number of the conversations, but these conversations are of multi-party, because one user has asked a question and there are multiple support seekers who can provide answer to the particular question. So, next we took help of a doctor in AIMS Patna. There is a doctor, Dr. Pankaj Kumar. So we took help of him, and with his help, basically, we basically converted these multi-party conversations into dyadic conversations. Because for our purpose, we need basically a doctor and a patient. We need this kind of conversations. So we basically he provided us some annotation guidelines, and then we employed some annotators who are graduate in English and linguistics, and they are very good in English, and they basically manually created the dyadic conversations from these multi-party conversations. And there are some extra guidelines that are also followed. So the annotators were asked to create a turn-by-turn exchange of dialogues between the user and the VA from the responses of the poster and the commenter, and make maximum uses of responses from the source conversation to create a dialogue. And the VA cannot impart any medical advice. So basically, we remove all the disease, all the drug names from the conversations, and the VA cannot impart any negative utterances. Can it like it utter any negative utterance? So all the negative utterances are also, the can are basically also discarded from this data set. So this is an example of a data set, like JNCAT is saying, I am really struggling to take more sleeping pills and just pass out. I want to not wake up for a week. I want to take the easy way out and just sleep away. He is saying that's not you talking, Jane. It's the depression. So, JNCAT is not the original name. JNCAT is a symbolic name. So it's the depression. Give yourself some TLC. Do something you love, like long bath with a glass of wine. Go online and play some mind numbering games. Retail therapy. Remember the butterfly effect. You are here for a reason that you are not allowed to know about. Hugs and keep venting. So the Jenkat is saying, I double my dose to sleep, but I am still awake and typing fine. He is saying, take a little nap. Lie down for 10 minutes. Shut up your computer now. It's the best thing for you. You won't be able to sleep unless you lie in the dark. Give it a try. Jenkat is saying, tired sleeping, and then my mom tells me we have to go. So I am out and about. I feel fine, maybe a little flowy and light. Tell your mom about the pills so she can keep an eye on you. And please don't do this again. I worry for you. Now Jenkins is saying, I won't tell mom because she will take them away and won't let me take anymore. And I can't just stop suddenly. I will wait for my doctor and tell him what's been going on. So with the virtual assistant, it's very easy to go from 2 to 3 and to 4. The recommended doses is there for a reason. And unless you are a medical professional, you should follow what they say. So then basically there are such conversations, and finally the virtual assistant is saying you need to take responsibility for your thoughts, feelings and behavior. It is not our fault we have this disease. We are not to blame, but we have to be responsible. Own it, take care of yourself. So in our data set, there are some 4,000 uttered dialogues and 14,000 utterances. Average number of utterance per dialogue is 3.70. Average number of utterance per dialogue is 47. Maximum user utterance length is 3321. Maximum V utterance length is 961. Number of unique users are 1000, and number of unique words are 59,363. So basically now our task is to basically automatically generate the virtual assistant response. So given the user's utterances and given the context, the task is to automatically generate the textual response. So basically we aim to solve the task of textual response generation between the user and the VA involved in the dialogue along with the conversational history. So there is a user response, there is a conversational history, and now we have to generate a response for the VA. So we developed two models, sequence model and the HRED model, hierarchical reinforcement learning based model. So, these are the two existing models. So sequence model, it can be also used, and the hierarchical reinforcement learning based model can also be used. So we are using different loss functions, cosine triplet loss, negative log likelihood loss, and we are taking a combination of these two losses. And that way we are basically trying to build a virtual assistant which is motivational type. And these are some results we compared with some baselines, and we are getting some blue basically blue score basically matches. There is an actual response, and the virtual assistant is generating some response. So what is the similarity between these two responses? That is they are captured by the blue score, and we are getting not very good blue score, but our generated responses are very good. Like here you can say an example, like suppose user is saying, I am so depressed and overwhelmed with emotion that it hurts, I can't breathe. So the ground truth is very long, like I am sorry you are feeling this way, just know it does not last forever. When you feel this way, just hold on to that and look to the future when it would be over rather than live in the moment. Just remember it won't last forever, though it may feel that way. Take care. Now our proposed model is generating this. I am sorry you are feeling this way. When you feel depressed, think about the future. Nothing lasts forever. Take care. So this is the these are the works. So I think yeah, time is up. So I should stop and take some questions. So if you have any question, please feel free to ask.
Ma'am, the blue score is 0.234. So how we can improve the blue score?
Yeah. So this depends on the data set only. So basically, that if we can increase the amount of data set, because data set creation is very challenging. For this mental health domain, getting good quality of data is very difficult. As I mentioned, that we crawl the data from the psychocentral, and from the psychocentral we crawl the data, and now we are using this data for building this particular model. So yes, we are creating more data. So I think if we can increase the amount of data, then we can build some better models. So that is the basically, these deep learning models are heavily data dependent. Data is the fuel, or data is the the oil basically. So if you can increase the amount of data, quality of data can also be improved, and then according to the model can also be improved.
But ma'am, blue score, as per my understanding, is for machine translation, the quality of machine translation. So
No,
is
so
it
here
is
also
it
it is a, yeah, here it is a generation task. So basically, that our conversational agent is generating a response, and you already have the gold standard data. No, like here you have. Can you see my? Let me show my screen again. So basically, already you have the gold standard data. Like machine translation, you have the gold standard translation. Similarly, here actual response is already known. Like here you can see this example. So here, if this is the if this is the user's utterance, then this ground truth is the actual response that is expected. Okay, and now we are getting this HRED2 plus ARL. This is we are getting. So basically, now we are seeing the similarity between these two. So blue score basically captures the similarity between the ground truth and the our predicted response. So it is string matching. In machine translation also, this is string matching. You have the ground truth translation, and your system is generating a translation, and then we used to do a string matching. And here also it is a natural language generation task. So your system is generating a response, and there is a ground truth response. So we are making a similarity matching.
okay, ma'am? If ma'am we changes the language, then can it work? For example, if it is Hindi or some other language, I mean, for that, what we have to do?
For that you have to again train the model. You have to again train the model. So basically, Hindi data we didn't get. So there is no such website from where we can get some Hindi data. But what we can do is that this English data can be manually translated into Hindi. Yes, so basically, if you want to develop something in Hindi, then you have to first translate the data into Hindi. So basically, you have to retrain the model in Hindi, because the vocabulary would be different. No, so basically, English is having his own set of vocabulary. So Hindi will also have its own set of vocabulary. So as the vocabulary will be different, so we need to retrain the model again.
Ma'am, other, for example, machine learning that you have used, I think, sequence to sequence model. So what are the other models which we can apply for this
So
task?
nowadays, this GPT or the Chat GPT, or this, all the, there is a BRT BART, there is a T5. These are all transformer based models. So you can easily utilize these transformer based models for this task. You can fine tune them. No need to train it again, but some last few layers you can fine tune with the help of this data.
What is the advantage of using this sequence to sequence model? I mean, here in this.
So it basically captures the context. Like, based on the context, it basically generates a send. It's a very, the base, like a very simple model. So sequence model is the base model of machine translation and also the basic model of the natural language generation. So it sees the context based on the previous words. Already, suppose some words are already generated. So based on the previous words, it will try to generate the next word.
Okay, ma'am. Thank you, ma'am. And ma'am, I just like to ask what IIT Patna, there is one department called the Center of Endangered Language. So what is their, I mean, job? I mean,
I think they are working. That is a basically linguistic department. It's not. It's with the humanities department. So they are doing some research on these endangered languages.
but they are
So
also doing some kind of the machine translation. I recently visited there, so they are also actually. I have also presented one paper from Angika to English. So I mean, it was the local language of Bihar. So that was for NMT, neural machine translation, and where I have also used this sequence to sequence and other models.
very good.
So
Very
that
good.
is why I'm just asking about the blue score and all, because I was
Okay,
also
very
getting
good.
a low blue score there.
Yeah, it's very. You do some human evaluation, okay? So sometimes blue score can be low, but maybe if you will do the human evaluation, you can judge the readability or the meaning, whether the meaning is preserved or not, readability aspect, so adequacy and the fluency. So you can do a manual evaluation also. Like blue score is not a good measure also. Sometimes maybe the same thing can be expressed in different ways. That's
Yeah,
why
ma'am.
human evaluation plays a very major role in machine translation in generation.
Thank you so much, ma'am. Thank you.
Yeah.
Is there any question? Okay, no question. Thank you, madam, for providing us with your precious time and knowledge. Your take on virtual assistants was quite insightful and detailed. The visual aids were very helpful in understanding the process of end-to-end dialogue system. You made us aware of the opportunity for automatic disease diagnosis in our society healthcare system, and your explanation of its working was very comprehensive. Your proposed hierarchical reinforcement learning based model and symptoms association investigation system was very interesting. The addition of the case studies in your explanation definitely made it easy to understand them, and I'm sure the participants gained enough knowledge from your extensive yet clearly presented project details. Once again, thank you, madam, for giving us an opportunity to learn from you. Thank you, madam.
Yeah. Thank you, the Dilip. Thanks a lot. Yeah.
Thank you, ma'am.
Okay. Yeah. Bye bye.